Good evening all, and welcome to tonight's TI Technology webinar hosted by TI Instruments Australia. When I get onto the right screen, we'll be even better. And this one tonight is called SACE, the Year That Was in General Mathematics, with Isabel Hoadley and myself. My name is John Baymans, and I teach mathematics to years 7 to 12 students at Lachlan Catholic College, Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And I'm really excited to introduce our Darwin-based trainer this evening. That is Miss Isabel Hoadley. Good evening, Izzy.
Good evening, John.
It's very funny, Izzy, to 1 minute be calling you Isabel and the next minute to be saying Izzy to you. Do you feel like you're being told off if you're one of those names, or are you okay to go between both?
I prefer Izzy because I do feel like I'm being told off, but that's fine.
Okay, well, let's go. Izzy is a colleague of mine at Lachlan Catholic College in Darwin, and she is an enthusiastic and dynamic teacher. I have to admit, I am somewhat in awe of biography, although completely justified when you see the professionalism she shows in her teaching and the respect her students have for her. Izzy, it is fantastic that you could join us this evening and share your knowledge. Thank you.
Thank you, everyone.
And please feel free to send in any questions at any time to Izzy and myself using the Q&A window on the right-hand side of your screen. And we'll also be using the chat window to send general messages. As you may have seen already, I've sent two out, both an introduction one and just we're about to start. As a general reminder, tonight's webinar is being recorded and will be available for you to re-watch or share with your peers and colleagues, or even students, on our on-demand webinar page on the TI Australia website and our TI Australia's dedicated YouTube channel. Excuse me. We hope that you don't have any audio issues, but if you do, try pressing Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. Okay, so with no further ado, let's get on with the content for this evening. So this was the webinar brief that we sent out and which you saw and enthusiastically joined up, so thank you for joining us, especially if you're live. It's been a big year. I'm sure that you're in the middle of doing reports, and if you are watching this on demand, I hope things are a bit quieter for you. So the key points from this that I'd like to bring out of it is that in the SACE subject outline, the role of technology, its importance in enriching our teaching and students' understanding and their efficiency in doing tests or just doing questions in general and the exam has to be skillfully used and appropriately used. And in fact, the word electronic technology comes up 32 times in the subject outline, which is quite a lot of times. Okay, so this is what we will be covering this evening in tonight's webinar. I will be talking about various apps. You all should be aware of polysynth, which I'll just be highlighting quickly, but there is another one called inequals that you may or may not be aware of for linear programming. Izzy will go through statistics, both the calculations and the graphing, and including residual plots. I will go on and show you how we can use the normal distribution with graphing. You should be aware of normal CDF and inverse norm, but hopefully you may or may not be aware of graphing, so she may just give you a few tips there. And then we'll go back to Izzy for some financial maths with a TVM solver. And although I put question time there, please send any questions you have to Izzy or myself during the webinar, because the whole point is to answer your questions and queries. So let's get going. Obviously, there's a question about solving a polynomial, but I'll just hold off on that for a second and want us to make sure that we're all on the same page when we're starting our calculators. You can see here that I've got TI Smart View. Hopefully that you have this in your school and you are using it. I find it a very useful tool to use with my students, either in this format where I have the big screen, or as I just showed you a second ago on a smaller screen when I'm working with questions. I can't really imagine my teaching and explaining to students how to do stuff without this. If you're still running the old system with the TI-84 Plus, which we actually can do on this one as well, please be mindful that you can get a free upgrade to the new CE. Just visit the website, and all the instructions are there on how you can actually go up to the new CE version. We want to make sure that the Smart View is on the new operating system, and so is the handhelds. So with the Smart View, we can do that by going to Men, just the same as we do on the handheld, and we can see what version we're on. And 5.3 is the current version. We can also go into Help, and check for upgrades through this as well. But 5.3 is the current system. Izzy, do you find that your students have the current operating system, or do you find that that's a bit of a challenge for you in your classroom?
No, I generally find that they've got it. I try and make sure that they've got the current one when an update comes up, and that just keeps everyone on the same page. But it's good if you can kind of, I guess, keep an eye on that.
Yeah. So to do that, hopefully this is one of your go-to buttons on your website, is the TI Australia website. And it will tell you constantly whether there's updates available, and emails that get sent out. But we can also do it this way. It's quite a nice, useful way. Is we go to computer software, and we will go down to the emulator. And you see here's your free trial of the CE. And here's the current version of 5.3. And we can simply follow this by going Update Now and choosing what devices that we want to check, and we progress from there. That then gives us a nice, when we do that and run through that system, it gives us a nice, let me just turn this down. It gives us a nice bundle of the operating system. It will update the Smart View automatically, but the operating system will come onto the side here. And I use TI Connect, which hopefully you've shared with your students and you use. So we get the TI Connect. I'm just going to turn my handheld on that I have connected at the moment. So this is my handheld that I have connected. Again, if I go on my handheld and just look at the memory, I can take a photo of that and just show you that I am actually on the current operating system, the same one on my handheld. But if it's not the operating system currently, we can click the catalog here, and I can simply drag and drop the operating system across onto the Calculator Explorer, and that'll update the handheld. I don't want to do that now, because obviously I've got the current operating system, but that's the way that I find it. I have this on my desktop in my classroom, and kids can then just do it automatically. Be also mindful that we can actually also do it from sharing the calculator's link to link, and we can do it through here as well, where it won't let me do it on the Smart View, but if we go through the link, then we can also share the operating system between calculators, so you can get the students to do it themselves. With the advantage of using TI Connect, and especially when we have screen capture, is this is a great resource for students to have documents. If I go to a new Word document and have documents that they can then, when they've got these screen dumps, they can take them straight across onto their assignments and have images straight onto their assignments that they can then work with. Izzy, did many of your students use that functionality with their two assignments they had to do for general maths?
Yeah. So most of them used the Connect software to do that and to take screenshots. I just found it was made it look a lot nicer than them just they wanted to just take photos on their phone of the screen, and it just never really looked very good. And so having that software makes it look a lot better.
It does, doesn't it? It looks quite professional. And if they've got the CE handhelds as well, that color functionality with the graphs really makes it look stand out as well. Yeah,
it does.
Yeah. Cool. I'm glad you agree with me. Thank you very much. You're making me look good tonight. All right. So going on with the polynomials, this is in polysym. So these are the apps that I said I would introduce. And we go into apps. There's polysym, number 9. Let me just shrink this back down again. I want to get rid of that. So let's turn off this side. There we go. And we're going to go into solving a polynomial. And we can see that the order of this one is order 5. So I would come across. Notice that these tab keys, and I have this in the screen like this so that students understand that these tab keys on, whether it be in an app or in other functionalities, actually allow them to access through the function keys here just below. And we can see, oops, I didn't do it correctly. So let's go back to main, and let's go back into polynomial again. Notice that I went across to order 5, but I didn't press enter. That will make life a bit easier. Next, A5, well that's 1. That's the 5th polynomial. And the reason I've chosen this one is I want to make sure that students understand that for x cubed, there's nothing there. So we need to make sure they understand that that must be 0 when they do that on the handheld. So that's all good. Minus 62. Enter. Minus 97. Notice that we use the negative button, not the takeaway button. That will give an error, and it will show them where that error is. And then if we go solve, and I worked this one out myself so I can set it up, there's our solutions. So we have 3 real solutions and 2 imaginary solutions. There's some really nice things here that we can see down the bottom that are underutilized by some people, and that's the store functionality. So sometimes, may not be in general, but in some of the other SACE courses, they may want to use those values. So we can store those values. And we can store the coefficients, so those are the 1, the 8, the 0, etc. We can store the polynomial and y equals if we wanted a graph, which is a nice little functionality. And we can also store the roots themselves in a list. So let's go to that one. That's my choice for today. And what list do I want to store it in? Well, let me store it in list 4. Okay. And if I press enter, then it says a list already exists. Okay, well, is that okay? List already exists. Well, I think that's okay. Let me choose a different one. Maybe it doesn't like the fact, and I think I've got some data in that one as well. All routes saved in non-real list. Okay, to list 3. Perfect. All right. So if I now then quit this, and I get out of this functionality and quit the app, number 6. If we now go into stats, edit, we can see that here, and there's the numbers that were already put in there, so that's why it didn't actually like that. It was saying, well, hang on, you've already got numbers in there, you can't put more in there. We can see that here are the numbers that come through. And another nice little feature is, I hope it'd be nice if I taught you something, I'm not sure I will, is that if we say list 3 and we put brackets and say the 4th line of that list 3, it will come up with that number. Were you aware of that?
That is new. No, I wasn't.
Oh,
that's
there
great.
You go. See how exciting that is. But obviously the advantage of that is we can actually store it as a variable, so we can store it as A, and then we could actually work with that. So then if we wanted to do some numbers with that later on. Again, not in the general course, but there's other things that we can do with that. So that's a nice little thing. Okay, moving on. So now what about solving a simultaneous equation? Well, again, back into polysym. We're going to simultaneous equation solver this time. How many equations do we have? We have 3. How many unknowns do we have? We have, oops, gone too low down. We have 3. I'll let them choose what I want it to be. That's okay with me. I'm going to go next. And we can see that we type them in here, and it even comes up with the same. The new version of the operating system runs like this. Okay. It goes to the plus. I find this a little bit of an annoying feature. I think it's in there so that students don't get to actually make a note of what that number is, but yeah, I find it a bit time consuming. Now again, on this one, what I'm looking for the students to see is that there's a 0 missing, so that's okay. We'll leave that. The plus, well, yeah, it is plus, and it's 4. It's minus, oops, it's minus, and 3. Notice it is the minus button this time. And again, it won't let them move on unless it registers that anyway, so that's okay. 1, enter on that. 4, take it away. 2 minus 7. And we'll solve that as well. And there we go. Again, these can be stored, they can be converted to fractions, and there's a nice little thing on simultaneous equations. Really nice little feature. And I use this as well with my year 9s and my year 10s when I'm getting them to confirm that they're getting their answers right and to show how they can start introducing the technology in. I feel at my school we could do it better where we need to bring that technology back into the earlier years so that in year 11 and 12 all they're actually doing is applying it rather than actually having to learn it. Izzy, how have you found it this year with your year 12s?
Yeah, well, I found that using the simultaneous equation solver has helped them so much with actually being able to do that linear equations topic, which I think is probably the most difficult topic that they find for the whole year.
Yeah.
And having those steps on the calculator, they can just put it in, and then you are looking at more the applications of the feasible, infeasible regions and things like that. Means that they save a lot of time, and you save a lot of time in class as well.
Yes. Cool. Thank you. Okay, so then just for my last bit is linear programming. There's a nice little app for this as well, which I think really reinforces the students' learning of this. I know that a lot of this they have to do without technology, and we could argue about whether this saves them time, but I think the visual and the reinforcing of their understanding and learning is really quite powerful with this. So we're going to go to inequalities this time, number 7, and it says that inequality menu is the second calculate button. Okay, so that's fine. We can see here that I've got these written down already, but in this format, they're not very useful, as we can only do y equals. So we would actually have to get the students to rearrange them into this form. And also they're inequalities, so we need to go down and change some of these. So the first one is y is, I always seem to go the wrong way. I don't know why that is, just my luck. I always seem to go the wrong way. The next one, we've got less than. Izzy, I'm hoping that you're keeping an eye on these. So there you go. Did it again. See, it went the wrong way again. How does that work? What's the problem? Right, this one here, greater than. Oh, you didn't go to the right place. Oh, that did it again. Shut up. And the last one, I'll just type in because I thought I'd save this one to go in now. So we can go, and if you don't know about your quick keys, we've got the alpha F1 for a fraction button, and we've got 10 minus x divided by 2. So don't try and get them to be too technical with that, but change the inequality. There's this one, and we're going to get it right. Oh, winner. What a way to finish. And we obviously need to put the x1 in as well. If you notice at the top here, there is an x1 as well. So let's enter on here. We need to put x is greater than 1. Okay, that's the second one. Oops. There we go. All right. And now I'll just make this full screen, and I'll show the other calculator just because I think this is more beneficial like this. So they're all now in there, and when we go graph now, then they're all there. And this is sort of the old way of how I was taught, was actually just to shade them all in, and then the most shading is the one. Hopefully I learned from that. Well, not hopefully, I did learn from that with my teaching. Well, it's much easier to shade what you don't want. We can get the calculator to do exactly the same. So if we go into second calc, we can actually go, there's an extra functionality here that wasn't there before. All right, and we actually want to go the intersection of this. And this is a really nice visual that students get to see as it cuts it up. And boom, there we go. So obviously the next thing that we want is their intersection points. And we can do that again using the calculator. We go across inequality, and we want to choose the points of intersection. So here's the first one, and we're going to store that. So we press the store button. Oh, and I've already gone through this because I was practicing this earlier. So stored it in list 1. And then I go arrow across, and it'll find all the intersection points. And you see up here that it's telling me where they will intersect. So I'm going to do arrow down now to find another one. And I would press store again. It will come up with duplicate because I've already done this before. So I won't keep doing that, but I'll do the same here and store that one, and then arrow down again. And there we go, I'll store my 4th one. So that's that. So now they're all stored, so that when I go into my calculator now, we can see over here that they're actually all stored over here. And this is, again, a really nice feature of this, that we actually can see what those values would be. And what would we then want to do? Well, it could either be a cost or a profit equation. So what we would then do, and this is not normally here, we would come up to here and name it. So I've named it cost. Okay, let's just clear that. And we can then say, well, okay, let's say that the equation was 3y plus 2x for the cost. Well, I can do that up here. So I want 3y, so 3 times the y value, which will be in list. There it is, the y value, plus 2 lots of the x value. And there it is in list again. And if I press enter, then it will tell me which one cost the most, or where the most profit was, depending on the question. And if that changes, then we can go up and change the values up here and redo it. Did you have a chance this year to use that with your students, is it?
No, I didn't actually, but I would do it again. If I was teaching general maths again, that's definitely a nice, easy way to do it.
Do you think that that would be too many steps for them to remember, or do you think that they would be actually okay with that?
Well, again, I think it kind of comes down to how early you introduce the technology to them. I think with the general maths course, as it is, you might spend a little bit too much time going through and they might get a little bit confused. But if we did kind of introduce it more at the stage 1 level and build on it in stage 2, it would work really well.
Yeah, cool, thank you. Now I've noticed that I'm talking quite a lot, which some people will say is no surprise. So we'll try and move on. The last thing I'd like to just show you is the way that we can actually put Excel documents onto the TI before. Most of the time we get students to type them by hand, but we can actually use Excel really nicely as well. So I'll just show you very quickly what I've done here. I've got an Excel document here, which I'll open up, and there's some points, some values. But when you save it and you go to File, Save, you must save it as a CSV file. Normally it's a Excel workbook, but you need to save it as a CSV file. When you do that, so let's cancel that. When you do that and you use TI-Connect with your handheld, you can then very simply drag and drop those Excel documents across onto that handheld. And it says how many columns you want it to be. Well, I want it to be in 2 columns in the list, and it will send it to list 1 and list 2. And if I now go to my handheld, and I'll take a screenshot of that to show you what I've just done, we can now see that there are those same numbers from that Excel document that are now over on my handheld, which is quite a nice little feature. All right. I can then equally, when I'm in this mode, I can actually send certain documents to my desktop. So I can choose where I want to send them. I would highlight them and send them. So we can see that over here, I now have, let's move this out of the way. Okay, I now have them saved as list 1 and list 2 on my desktop. And then I can equally, on my handheld, on my smart view now, as it loads up. Is that my smart view? Yes, it is. I can highlight those, and I can drag and drop those across onto my smart view. So let's send those across now. Those 2 files are now on smart view. Let's go back to my handheld, and we can see that those same Excel files are now in, panic for a second, but they're way back over here. There they are. There are the numbers. So it's a really nice feature where we take an Excel document, we save it as a CSV file, we use TI-Connect to send it to our handhelds, we can save them back onto the calculator, and then we can put them onto SmartView. I think updated versions of SmartView will allow us to put it straight onto SmartView versus just a nice little way around. And then the students can easily disseminate that data, whether they collected it in science or off the internet, or from any other statistical source. They can actually then share that amongst each other, either via emails using the documents here, or they can actually just use the link functionality on here. So that's enough from me, Lizzie, to start with. I'm sure that people would like to know more about statistics from you, and I know that you're going to use those same numbers, so I'll pass over to you.
All right, thanks, John. Are we all good?
All yours. Good luck.
Perfect. Okay,
Fantastic.
so I'm going to talk about some statistical modelling, and what you should see on the screen in front of you is just a comparison between the key questions and concepts from the SACE outline and how we would use technology to approach these. So I won't read through them, but they are there. And as John said, the first thing we're going to look at is using that same data that he had on Excel just before. So the first thing, whenever students are doing a SATs question, that they need to make sure they've done is got their diagnostics turned on in their calculator. So to do that, we go to Second, Catalogue, and scroll down. John, I don't know if you know a quicker way of doing this, but I've just been scrolling down all year.
Yeah, there's a much quicker way, I'm afraid.
Okay, I'm sure there is.
If you go into mode,
yep.
Then there is Stat Diagnostics, and you can just turn it on down there.
Oh, perfect. Okay,
So
all right. So we can do that. You can, yeah, perfect. Okay, so you can see I've already got mine turned on, and I guess if students are getting confused, they can use the catalogue as well, but this is much easier.
With catalogue,
okay, so
if you're finding other things, you can also use alpha and then use the letter, and it will take you straight to what you're looking for as well. So if you were in catalogue and want to find other things, you can just do alpha D, and it will take you straight to anything beginning with D.
Perfect. Okay, so from here, looking at this question, I think the biggest thing that my students would probably struggle with the most is the fact that you've got a 3-row table. And obviously, if it's a bivariate statistic question, you're only looking at having 2 lists of data in your calculator. So the first thing I usually get them to do is to circle their X and Y variables and compare that up with the data that they've got in the question and make sure that that's what they're inputting into their list 1 and list 2 on their calculator. So I've got it circled here. And so that should make it nice and easy for them to then put that data into their screen. So I've already done it on my calculator. So if I go into Stat and then to Edit, you should see it in the list 1 and list 2 there. So the first part of this question that we're really looking at is looking at finding the coefficient of determination for a linear regression on the data in the table above. So to find that, we go back into Stat, across to Calc, and we're looking at the 4th linear regression. And this is really important, but I'll come back to why in a minute. So we go Enter on here. They've got list 1 and list 2. And the other thing I usually get them to do at this point in time is to make sure that they're actually storing their linear regression equation into their Y variable on their calculator. So to do that, we go to vars, across to function, and we're selecting the Y1 variable. From here, oops, sorry, I just got out of it. Okay, so from here, if we calculate that, we can see that we end up with our A and B variable, R squared, and our R value as well. And like I said, when you go into your Y equals, you should see that linear regression equation saved into the Y equals in your calculator. The reason why I think it's important for them to store it straight away is we were doing a model for our investigation where we're looking at rates of coffee cooling, and because the temperature in Darwin is quite constant, there actually wasn't a big decrease. So by saving that equation, you got it to quite a, I'll just go into it so you can have a look. You have it to quite a high number of decimal places, so we could actually compare the equations a little bit better doing it that way. Okay, so looking at the question from here, so we found our coefficient of determination. For the second part, we're just comparing that, and we're writing our equation with our line of best fit in terms of C and T to get full marks. Now, I mentioned before that it's really important that students are using the 4th linear regression as opposed to the 8th one. And that's because if I just go back to this screen where we can see the key questions and concepts, SACE has actually defined their linear relationship as y equals ax plus b in the content. And so what they want is for a to be the slope of the graph and b to obviously be your y-intercept. And if students are using that a plus bx function, which is number 8, they might get confused if they have an interpreting question, such as that last one on that page, which says state the value of a, which is the slope, and interpret that value in the context of the question. So I would recommend that you only advise your students to use the 4th Linred function and not the 8th Linred function. Okay. From here, the next part of the question just looks, thanks. So from here, we're just looking at using the equation in that we found from the parts before and solving to find some x and y values. So the first one asks for the carbon monoxide concentration when the traffic density T is 250 vehicles per kilometre. So if I go back into my y equals, I've still got my equation there, which is nice. I also want to check that my stat plot is turned on and that the list 1 and list 2 are correct, which they are. And then I want to make sure that my window is set up correctly. So for this question, I'm looking at having an x value from 0 to 150, the same as what it was in the question originally, and we're looking at a y min from 0 to 6. So if I graph that, I should get the line of best fit and the statistical data all on the same screen. So I'm going to go through 2 different ways that you can kind of go about solving for this equation. The first way is to use the line of best fit on the graphing calculator screen to find where x would be equal to 250. So to do that, we've actually got to reset the window, and we're going to have to increase that to greater than 250. So I'm just going to go with 260 to be safe, and graph that, and then we can use the second calc value function, type in 250, and we get our y value, which is 6.24. However, I do find that, especially with the general math students, and even with some of my math methods and spec students at stage 1, they really struggle with changing the window to being able to find their value, and they do often come up with an error if they haven't set the window correctly, and that puts them off straight away. So another way that you can kind of do this is to use the alpha S4 function, select Y1. We're going to type in 250 as our X value, and that'll just compute straight away to having a Y value of 6.24. And just so you believe me, I'll redo this with an X value of 500. Because obviously the window was set to 260 before, and we can see that we end up with a y value of 11.37 in this case. So they are the 2 different ways that you could probably go about.
That's linked.
Yeah.
Oh, sorry, Lee.
No, that's fine. Yeah, no, it's fantastic. It really makes a lot of sense, and I think it's really easy for the students to use. John, do you find that you're like even
nicely with the function stuff as well that you get students to do where they're doing f of a value. So I know it says y, but even so, sometimes it's g or h anyway. So having it as y1 bracket just fits nicely with that function aspect for students in other courses.
Yeah, definitely, especially for the more the methods and the spec students as well. It's really a nice way to do that. Okay, so from here, the next part of the question wants us to solve for a y value instead of an x. And the way I've got my students to do this all year is just to add in a second y2 with the value that we're solving for, and then finding the point of intersection between those 2 lines. So once in the blue line, once in the red line, and then in the middle. And that's really nicely, and I think it's definitely, you're doing that a lot when you're looking at the linear equations topic, and then you're also doing it a lot when you're looking at the statistics topic. So there's quite a lot of nice repetition there that we can use to really build on their calculator skills. From here, the next question is probably at a slightly higher level where we're looking at residual plots. And what we're looking at is, again, modelling the bivariate statistics and comparing whether we think a linear model or an exponential model is going to better fit our data. So the biggest thing for here is I've inputted that data already into my list 3 and list 4 in the calculator. Now, usually I wouldn't put data into list 3 and list 4 because I find for the students, if they just keep it in 1 and 2, and 1's always their X variable, 2's always their Y variable, it's a lot more consistent, especially for the general maths students. But I put it into list 3 and list 4 just to save a bit of time today. So what we're looking at for the first part of the question is comparing why an exponential model might be more appropriate compared to the linear model that we looked at before. So from here, obviously, we're looking at the 2-mark question, so we want 2 things. We want to look at the shape of the data, and we also want to look at the R-squared value. And even though it's the regression, residual plots are already drawn for us, it's still kind of quite important to go through how we would draw that on a calculator, say for stats investigation, where you want to be able to take a screenshot of those plots. So to do that, what we kind of first want to do is we want a linear residual plot. I'm going to go to Stat, Calc, down to the linreg, and I'm going to input into here, again, our Y variable function Y1, calculate that, and hang on, sorry, I forgot to change the list. Sorry, bear with me. So we obviously want list 3 and list 4, and this is why I get the students to generally tend to always use list 1 and list 2 just for that kind of consistency. So we want list 3 and list 4, and I'm going to store that into Y1. Oh, geez. Hang on. Okay, store it into Y1 and calculate, and we end up with our regression. And again, we should have the same R-squared value as what we're given in the question. So from here, to then go and draw that residual plot, we're going to go into stat plot. I want to make sure that my X list is list 3, and that my Y list is the residual plot of the linear regression that we found before. So I'm going to put that in. I'm just going to change the window to reflect the same window shown on that question. So from 100 to 200 and -30. Sorry.
Did the old take away rather than the negative?
Oh, just using the
so you did that on purpose,
computer
didn't you?
instead of
just so that you show how
absolutely.
you use the go-to button.
Exactly. So from we want obviously -30 instead of -30, and a maximum of 50. So now if I graph that and remove the 2.5 that I had in before, ignore the line of best fit for the moment. We'll just leave that in there for now, but we should be able to see the residual plot really nicely. And the best thing about this, I guess, for this question in particular, is you'll notice that part B says to identify an outlier. And so they can actually go through and trace that. And they should be able to see, I don't know if you can read it from the data, but there's one value of 185 and one of 186. Obviously, they're quite close together. So they should be able to see really nicely that that outlier is at 186 and not at 185. From here, if we then want to make an exponential residual, we do the exact same thing, except when we do our calc, we want to use the exponential regression instead. Still list 3 and list 4. We still want to store it in Y1. And then calculate, And then now I'll just double check my stat plot, make sure it's still list 3 and residual, so that's good. So now when we graph that, we should see the exponential residual instead. Okay, from here you're just doing pretty much very similar steps to before, where we're using our models to predict based on removing that outlier that we found before, and then saying, making some predictions. Okay, so John, I'll hand back over to you for normal distribution.
Fantastic, Daisy. Thanks for that. Daisy. Oh, I was thinking about one of my colleagues who's done some of these webinars as well. Izzy, thank you. It must be ending in Y that caught me out there. That's enough of making excuses. I'll move on quickly. All right, so normal distribution. Most of us should be using and aware of the fact that we have normal CDF and inverse norm when we're going from percentages back to finding the values on the curves, to find certain values that give us percentages. But also, there's a nice little function for graphing it as well. If you notice that in this distribution, we actually have a button here called draw as well. And that's a really nice addition to get kids to see the visual of actually what they're drawing. And with this question here especially, it adds another dimension. So I'm just going to set my window up first so that it looks like this. There's a nice little feature of this as well, because by the students having to do it, it makes them actually think, well, how high would this actual graph be? And that's a really nice learning experience for the students to think, well, hang on a minute, we know that in total it's only 100%, or really in this case it's only going to be 1 if that was all at this value. But since it's spread out over 1,200, it really isn't going to be very high to have an area of 1. And it's really nice for them to play about with this and see actually what happens. Obviously, I've done all the groundwork already, and it's very small. It's 0.005, gives us a nice graph of that. So I'm going to leave it like that. So at the moment on our graph, there's nothing there. But if we go now back into distribution and go across to draw, that allows us to shade norm. Now, normally you could use this to actually shade a certain region. I just want the graph to be drawn. So I'm going to use the same functionality. Lower, negative E99, that's fine. Very small, a very large negative number. The upper, I'm not really too worried about it, so I'm just going to keep it away from 4,500, so I don't need to worry about it. So let's just set it at 200, it's not the important thing. My mean is 5,100, and the standard deviation is 200. And like was happening with Izzy, it always catches you out, and you think it's just going to do it. You must come down to where it says draw and press enter on that. And there's that same bell curve that we can see here. Notice that it's only drawn on there, so it's like a student actually drawing it on in pencil or electronic pen. We can't actually do anything with it. The trace doesn't actually work on this at all because it's actually not drawn. There's no actual graph here. It's just on here, just drawn loosely. Sounds a bit weird, but there you go. But if we then go to what the second part of the question was, that I love these sort of questions. I just think it's really great. And this is a fantastic question by SACE, where normally, traditionally, they would keep the mean the same and change the standard deviation, but I like the fact that they moved the standard deviation on this one, and they moved the mean and they changed the standard deviation. I thought it was a very clever twist on the classic question. So we can now, and with the CE as well, we can do this on the normal 84 plus, but there's a nice little feature because obviously with the CE you've got the color and the pixels are so much better. We can actually do a bit more of a more detailed job. So we go back into shade norm again. I won't worry about the way we're looking at the bound, but I will change the mean now 5,300 and the standard deviation to 100, and I will change the color to a different color. Let's go blue. And if we now press draw, then we get that nice little feature where students can actually compare them quite easily. And I find that just this visual, whether it be in the exam or not, I think the exam sort of irrelevant. It's just that visual in their learning in the classroom. Oh yeah, it makes sense that if we narrow the width, those 3 standard deviations off the mean in both directions, and we squash it in, but it still has an area of 100%, then it's got to go somewhere, so it's got to shoot up. And I think that's a really nice feature and looks great on the colour calculator. So what do you reckon, Izzy, you like that?
Yeah, I think especially for the general math students, being able to visualise everything is so important for their understanding, and so yeah, it's fantastic.
Cool, thank you. And something that somebody mentioned, I looked at in the chat window, was how do we get students, we may have the same operating system, so remember I showed you how we can all have the same operating system. We can all have the same operating system, but sometimes it's frustrating that we're not all on the same page. Literally, students have little glitches in there. I know that in the past, students like to hide silly things down the bottom here in Y0 so that their friends miss them. How do we all get the same starting page if I'm trying to teach something, especially with some of the younger years where we're introducing these calculators? And the easiest way that I've found to do that is in the reset, number 7. You can either just reset the defaults. So if I do that now on this calculator, then what that does is just sets the defaults back to normal. So the window goes back to -10 to 10, and the colors go back to the traditional colors in here. But if we have data in here, that still stays there. Nothing changes. But if I wanted that, and also all the stat plots get turned off as well. But if I did want it all to be back to the norm, then we also can go into memory, reset, and do all RAM. So that's all there. The memory on there that most of the stuff's stored by, and we can press reset on that. And that will then reset everything. So now in stat, there's nothing in there. It's all been wiped clean. All that hard work I did earlier has been cleared away. But we then easily can start, and students don't have to worry, oh, my calculator is saying this and my calculator is saying that. And as Izzy showed when she did hers earlier, the go-to, I don't know about you, Izzy, but a lot of my students don't use, when there is an error that comes up on the screen, they don't like to use the go-to, they just press quit. And it frustrates me that the calculator will tell them where the fault is. So I'm never sure what's going on there. But I'll pass back over to you, because that's my little segment. And Izzy, I know you're going to bring it home with a bit on the TVN solver, which is another great feature of the TI-84.
Yeah, definitely. Okay, so again, what I've got here you should be able to see is just some things that we can do to use technology with financial modelling. And the main thing, of course, we're looking at here is the TVM solver. So again, I've got some questions from this year's exam, and I'll just work through a couple of aspects of them, and looking at TVM solver, also looking at the effective rate function, so students can see how to use both of those really effectively. Okay, so our first question is looking at a gentleman who's depositing some money monthly. He doesn't want a health fund, so he's saving some money to be able to afford any kind of cost that he might have in the future. So from this, when we're looking at TVM solver, it's in apps, it's the first thing in finance, and it comes up with a screen like this. And I'll just clear all the stuff that I've had in there before back to 0, but don't clear the P-Y and C-Y because that will come up with an error again. So the main thing when I get students to do this is in an exam question or in a test question or even things that they're working through in their textbooks, I like to make them actually write out what they see on the screen straight away, and that provides them, I think, with just a bit of consistency in terms of their own reasoning for their questions. So from here, we're looking at calculating how much money Ezekiel has in his account after 5 years. So from here, the first thing I get students to do is to fill in the N part on their TVM solver. And this is obviously the number of compound periods for the whole amount of time that he's depositing money for. So we're looking at 5 years, and he's compounding, this money is being compounded fortnightly, so we're looking at a compound period of 26. And then the next thing I get them to fill out after this is to go straight down to the P-Y and C-Y and change that to 26 as well. And I find if students leave that to the end, quite often they've forgotten what they've done before, and it just saves them a little bit of time to do it this way. From there, they fill in the interest rate, which is 3.45%, and remembering that you can keep that as a whole number as opposed to a decimal in TVM Solver. And then the next thing is filling in the present value, payments, and future value. And the biggest kind of misconception with this is looking at using the negatives with the TVM Solver. So the way I kind of tell my students to go about it is to think about if they are this person, if they're giving up money, that's going to be negative. If they're getting money back, that's going to be positive. So in this scenario, he's depositing $64.50. So that's going to be negative $64.50 because he's putting that money into the bank. And then, hang on, sorry, I've done it as subtraction again. So negative $64.50. And then when we're solving for our future value, we get a positive amount back at the end. So that's $9,145. Okay, so that's probably, I guess, the biggest issue that students have, and we'll go through an example in a minute where they're looking at having two things that are negative in the calculator at the same time. I'll just put that up on the screen for you to have a look at. And then the second question I'd like to go through is this part C, which is looking at inflation rate over the duration of the loan that he's going to be taking out money for. So he wants to wait 12 years for a surgery. His inflation rate over that 12 years is 2.8% per annum. So what I've got up on the screen there is just the classic inflation calculation that you run through with students when you're doing this. But we can also use TVM Solver to work out what our total amount is at the end. And I think the benefit in doing it this way is then if they have a question where they have to solve, and if they're, say, given the inflation rate, given the final amount, and they want to find the initial amount, that they don't have to go through and actually use algebra to solve, because that is one part where the general math students do generally tend to get a little bit confused. Okay, so in here, we're looking at inflation for 12 years, and inflation's always a yearly amount. Our rate is for 2.8%. Our present value is that $17,000. Get rid of that payment. The present value, and so P-Y and C-Y go to 1. And we're solving to find our future value, which is then going to be $23,679, which is the same as our calculation would have. Now, whether or not students find it easier to do it using a TVM Solver or to just do it by hand, that's up to them. But I do think that, for example, if we knew that inflation averaged 3% and it was the same amount and we wanted to find that present value, we could then solve for that and we'd find that it would be $16,608 instead. Okay, for the next, I'll skip over part D, but I'll put my answer up anyway in case you wanted to have a look. And we look at the next question from the exam, which said that Hossam has saved $7,520 towards his goal of travelling overseas, and he wants to put this money into a savings account for 2 years. Now, I'm not going to exactly use this question just because I feel like that second part with the account 2 might be a little bit ambiguous. And what I want to really show is how we use the effective rates function on the calculator instead. So if I just skip over here, I've just made up a new possible accounts that he can choose from, which is account A offering a rate of 5.2% compounded monthly, and account B offering 5.6% compounded quarterly. Now, students can do this much easier by going into finance, and then at the bottom of finance, which is labelled C, is this EFF function, which is looking at effective interest rates. So from here, if we go into this, and we just type in 5.2, and we're looking at compounded monthly, so that's 12, we can really nicely and quickly get our effective interest rate. And then compare it with our second function, which I won't worry about for now, but we would end up being able to see both effective interest rates and compare that really easily. From here, I'll just quickly go over one last question, which is looking at a comparison rate. So with a comparison rate, we want to take into account the amount of fees that we have in an account. And the main reason why I want to look at this one is because with TVM Solver, we can really nicely do calculations in the solver without going back into the main screen. So again, if I just quickly make fees back to 0, for this question, we're looking at 7 years and we're compounding monthly, so 7 times 12. We're going to change the P-Y and the C-Y to 12. Our interest rate is 6.15%. Now, for our present value, we're looking at a loan amount of $80,000, and we want that to be positive because we're getting the money back at the, we're getting the money at the start from the bank, and then we're paying it back. So positive $80,000. There's also $200 in fees, and there is a $7 fee for 7 years, and that's being taken monthly. So 7 times 7 times 12. From there, we're wanting to solve for our payments, and we want our future value to be 0 because that's what we don't want to have any money left to pay back at the end of the loan. So if we solve for that, we end up with our payment value of $1,186, and what you should see above is that present value has changed that whole calculation that we put in initially to the total amount that we want to solve for. And so that's just a way that we can kind of eliminate students going back and forth between screens when they're doing their exam and save a bit of time. Again, I'll just put up the rest of the answers to that question if you want to have a look. But I believe we're running out of time, so I'll pass back over to John.
No, that's great. And I think there's some really nice features that you have and tips. I think that the tip about clearing all the screen values and putting them into zeros and ones, I think it's really powerful because I know that my students in the past have got confused what values are actually supposed to have. They have changed, which ones they need to change. So I encourage my students to highlight the bits in the question that they need to use. And the positive negative tip, I think it's a really lovely one because that's another one that even as teachers sometimes we're going, right, is it positive, negative? But if you use that analogy that you used, I think it's a really it's a great example.
Perfect, thanks. Jen, have we got 1 minute?
Yeah, go for it. Yeah, please do. This is great.
Perfect. Perfect. Okay, so what you should see on your screen is this is just a list of topics for general maths, and what I was kind of reflecting on at the end of the year is how I would maybe go about organising the topics a little bit differently if I was teaching this again. So I started off with the order that it's seen on your screen, and if I was doing it again, I think I'd probably start with linear relationships again. But straight after that, I think I'd actually go to statistical models because a lot of those skills that you use with the TI for the programming, you also use again for bivariate statistics. So you might actually save a bit of time and energy and revisiting concepts and just be able to focus a bit more on applications if you don't have that break in between. Then financials, probably the slightly different topics, that'd be the third one. And then I'd probably finish looking at matrices and discrete, which also fit in really nicely together as kind of one big topic. And that's 100% finished.
No, I think that's great. And how did your students find it this year? You know, obviously it was a new course, and so they didn't really necessarily know any different. I suppose it's more from your perspective. But did you enjoy teaching some of those aspects with the students?
Yeah, I did. I really enjoyed the linear relationships, and I also really enjoyed the discrete models as well. I think they're really nice topics for the general maths, and I had a kind of interesting subject this year where I was teaching the vet students general maths, and so some of those things like discrete models, and we were looking at the fastest way that you could finish a task if you were on a trade or you were organising other people, and we had some really nice conversations about that. So I do really like the course. I think there's a bit of work in making sure that the stage 1 reflects how difficult the stage 2 is. But I thought it was really great.
Well, thank you very much. I think that you looked more the pro than I did, so thank you for your involvement tonight and your contribution to this, Izzy. So thank you very much indeed. Okay, so we will begin wrapping things up. I have sent out through the chat window if you do have any questions. Please try and get those through to us. Izzy and I will endeavour to answer them. And we also will use that for adding to planning a future webinar. Next week we're running one to do with the methods course. So hopefully you may tune in again for that, or some of your colleagues may. When you leave the webinar tonight, a brief survey will automatically appear here in your browser. Your feedback guides us as we plan future online events, and we do listen to your feedback. So we hope you do share your thoughts in a post-webinar survey. Your certificate of attendance will be emailed to you in the next 48 hours, along with a link to the on-demand and YouTube version of the recording. So if you'd like to watch any of that again or share it with your students or your peers, then please, we encourage you to do so, especially with thinking of students teachers who perhaps are teaching it for the first time next year. So as we leave tonight, if you do need any post-webinar follow-up, please feel free to phone or email TI. I know they would love to hear from you, and they're always willing to help and advise, and to perhaps put you in touch with people that can answer your specific questions. And that is it. That brings us to the end of tonight's webinar. Thank you very much, Izzy, for everything you shared with us tonight.
Oh, thank you for having me.
Absolutely our pleasure. I know that from the feedback from the participants, they really enjoyed what you had to share, so thank you. And equally, thank you for everyone for joining us tonight. We do it for you, and I hope you found it useful and beneficial. I hope it enriches your teaching, and more, as importantly, if not more so, your students' learning. So thank you very much. Good night, and we hope to see you back online again soon. Thank you. Bye.